Hey everybody, this is Mr. Misuro again, and today I want to continue talking about how water moves in the ocean by talking about the most common way that people think of water moving in the ocean, waves. It's kind of a loaded lesson. We're going to talk about a lot. We're going to talk about what causes waves. We're going to talk about breaking waves. And then we're going to talk about not only breaking waves, but also other types of waves, rogue waves and tsunamis, these waves that don't break when they get to the shoreline. In order to really understand waves, you have to understand a little bit about the anatomy of ocean waves. And ocean waves, they have four parts to them. The first is this top part. It's known as a crest, the highest part of a wave. Opposite the crest is the lowest part of the wave, the trough. And if you were to measure the vertical distance between the trough, the lowest part of the wave, and the crest, the highest part of the wave, you would get the wave height. Wave height is probably one of the most misunderstood things about ocean waves, and that's because wave height sounds really misleading. If I talk to you about a 3-foot or 4-foot wave, you think, well, I'm 5 feet tall, 6 feet tall, so that's a tiny wave. The thing is, wave height is measured from the trough or waterline, not from where your feet are. If you're in waist-deep water, if the waterline is at your waist and a 3-foot wave hits you, that wave is hitting you directly in the face or above your head even in some cases. Wave height is measured from the waterline to the top of the wave, the trough to the top of the wave, not your feet. The last part of the wave is the distance between these two crests, and that's called the wave length. So now we have some common terminology about how to talk about the different parts of the waves. Let's talk about what creates waves. Waves are created by wind. The waves that we see in the ocean are created by wind. And not just any wave will create wind will create a large wave. What wind needs to have certain qualities in order to create large waves. Specifically, it needs to be fast-blowing wind, blowing over a large distance, what's known as fetch, for a long period of time. Fast-blowing wind blowing over a large fetch for a long duration is what will create the largest waves. Slow moving wind blowing over a large distance for a long duration, or really soft blowing wind over a small distance for a short duration, or any iteration, those won't create the truly large waves that people like to look at. Only wave of these three qualities, high speed, large duration, large fetch, and long distance, is going to create the largest waves. So that wave is created out in the middle of the ocean. Now it gets to the shoreline and it breaks. And my question becomes, why do waves break only when they get out into the shoreline? Why don't waves break in the middle of the ocean? And the answer to that question is it has to do with the shoreline itself, specifically an area of the shoreline known as the surf zone. The surf zone is this shallow area of the ocean, and as the wave enters the surf zone, its bottom begins to rub up against the bottom of the surf zone, and this slows the wave bottom. The top of the surf zone doesn't slow. The top of the surf zone the top of the wave doesn't slow. The top of the wave isn't rubbing against anything. So as the bottom is slowing down, the top keeps going. And this produces the first part of a breaking wave, a leaning. The bottom slowing down and the top keeping on going as it enters the surf zone means that the wave begins to lean over. But just leaning isn't enough to get a breaking wave. A lot of things lean and they don't fall down. The Leaning Tower of Pisa leans, it doesn't fall down. So you need more than a lean in order to get a wave to break. And that comes in this second stage, a squish. As the bottom of the wave slows down, these other waves behind it are still moving at the same speed. And so these other waves start slamming into the backside of this slowed down leaning wave. That causes the wavelengths of this slower moving wave to shorten. And shortening the wavelength kind of pushes up the wave height. As the wave shortens in its sides, it starts popping out from the middle. Now we have the wave not only leaning forward, but we also have the height of the wave, the middle of the wave, the crest of the wave building. And as a result, between the lean and the squish, that's how you get a splash. It's both a leaning and a squishing that causes waves to break. I should mention that waves breaking is a little bit more complicated than this. There are a bunch of physical equations that you can do that have to do with the depth of the surf zone and the texture of the surf zone and how much it slows down water. But lean, squish, splash is good enough to understand for our purposes how waves break. It's a leaning when it enters the surf zone because the bottom begins to rub up against the bottom of the surf zone. The top keeps going. Other waves start slamming into its backsides, causing the sides of the wave to squish in and the top of the wave to pop out. And then eventually, between a leaning and the height building, you get a splash. When you look at waves on the Jersey Shore, you probably have noticed that those waves look different than waves, let's say, in Hawaii. And that's because they are different. There are two different waves. Breaking waves, the waves that do break on the shoreline, are either plunging breakers or spilling breakers. And what makes those waves different is the surf zone that creates them. Plunging breakers are created by steep sloping surf zones. This steep slope slows down the bottom of the wave a lot, way more than the top. And as a result, as the bottom slows down a lot, the top keeps going at the same speed, but basically the wave's legs are taken out from it. So now the leaning is much more dramatic, the squishing is much more dramatic, and you get a much more dramatic splash, this sort of curling crest. The crest plunges over on itself, and that's how it gets the name plunging breaker. Steep sloping surf zones you would see more in Hawaii or some parts of California. That's where you would see those types of breaking waves, plunging breakers. In the Jersey Shore, we don't have a lot of steep sloping surf zones. Instead, we have much more gentle sloping surf zones. Still an area that slows down the bottom of the wave, but just much less dramatically. And as a result, you don't get as much of a lean and you don't get as much of a squish, and so you don't get as much of a splash. Spilling breakers don't curl over on the top. They basically just kind of froth, and that froth rolls down the side. It's really important to understand, and for me to point out at this point, that spilling breakers and plunging breakers are created by surf zone. They're not created by wind. Wind determines the size of the wave you see. Surf zone determines the type of the wave you see, plunging or spilling breakers. You can have very, very large spilling breakers if fast-blowing wind blowing over a long distance for a long period of time produces a wave on a gentle sloping surf zone. You can produce very, very small plunging breakers if soft blowing wind blowing over a soft distance for a soft period of time or short distance for a short period of time blows into a steep sloping surf zone. Small plunging breakers and large spilling breakers exist. It's just that you don't typically see them. You typically see these huge plunging breakers and these very, very small spilling breakers. So you get it in your head that spilling breakers have to be small and plunging breakers have to be big. And that's not true. Wave size is determined by wind. Wave type is determined by surf zone. There are also waves that don't break when they get to shore. There are waves that aren't governed by these same rules. They're not produced by wind and they don't break when they get to shore. And I'm going to call these special waves, and I'm going to talk about two of them now. I'm going to talk about rogue waves first and then tsunamis second. Rogue waves are our first special wave, our first type of wave that doesn't break when it gets to the shoreline. Rogue waves are these randomly occurring huge waves that appear out of nowhere in the middle of the ocean. If they hit a ship, they usually sink the ship or at least capsize it. And the reality of rogue waves is, up until a couple of years ago, no marine scientists thought that rogue waves existed. Marine scientists knew that waves are created by wind, and you can't have this randomly occurring huge freak wave because that would mean you would have to have a randomly occurring huge freak wind blowing over a long distance for a long period of time, and that just can't exist. But with shows like The Deadliest Catch, with shows like Whale Wars, we started recording what a ship sees 24 hours a day, and lo and behold, we started recording some rogue waves. So now we have to explain how you get these gigantic waves that appear out of nowhere. And marine scientists don't actually know the answer to that, but they think it has to do with this thing called wave construction. Wave construction happens when the crests of two waves align and the troughs of two waves align. When crests align with crests and troughs align with troughs, waves basically pile up on top of each other. Their height begins to add, and you get a randomly occurring larger wave. That's wave construction. Marine scientists think that in all this chop, with wind blowing water in every direction, producing what we usually see on the water, that randomly you're going to have one wave's crest align with another wave's crest, and that's going to produce a larger wave. In fact, if you run the numbers, about 1 out of every 23 waves would technically be a rogue wave if it's created by wave construction. It's just not really notable. It's just about twice as big as the waves around it. And in fact, if you've jumped waves in the ocean, you've noticed this. If you jumped a number of waves, you see that one wave kind of appear out of nowhere. It's like, wow, that wave is bigger than the others. Well, that's probably the result of wave construction. Rogue waves that sink ships, these waves that are 7, 8, 9 times as high as the waves around them, they occur on the order of 1 in a billion or 1 in a trillion. They're very, very rare, but you spend enough time on the ocean, you might be the unlucky one that gets hit by one. Rogue waves, large waves that appear out of nowhere, that occur due to wave construction. Tsunamis are a little bit more familiar to people. These are large waves that don't break once they reach the surf zone. And really, the difference between a tsunami and a breaking wave is that tsunamis don't break. They just keep on going in. Tsunamis aren't created by wind. Tsunamis are created by earthquakes. And that's an important point because they're not created by wind and because they don't break, a lot of people don't understand that tsunamis don't actually look like breaking waves. If you were to picture a tsunami in your head, or if you looked at, Hollywood would like you to think that tsunamis look like this. That's just not true. This is a plunging breaker, it looks like. This is what a breaking wave looks like, a wave that's created by wind, a wave that breaks because of a surf zone. Tsunamis aren't created by wind, they're created by earthquakes. They don't break when they get to the surf zone. Tsunamis don't look like this. They look like this, basically just kind of a lot of white water flooding into an ocean. And they're not nearly this large either. The largest tsunamis that can happen are really only about 50 feet-ish tall. Any larger than that, the earthquake needed to produce them would be so large it would be almost impossible. It would be physically impossible to have. Tsunamis can also be caused by landslides. They can also be caused by meteorites, but these are more experimental ideas. What we know causes tsunamis 100% of the time, if the conditions are right, are earthquakes. So tsunamis caused by earthquakes, rogue waves caused by wave construction. So a lot to digest in that lesson, but basically all about waves, right? We know that breaking waves are caused by wind. And we know that they break because they enter into the surf zone. They start leaning over because their bottom begins to rub against the bottom of the ocean. Their top keeps going and they start squishing in on themselves when the other waves plow into the backside, and that causes them to break. And we also know that breaking wave can be either a plunging breaker if it's a steep sloping surf zone that's causing the wave to break, or a spilling breaker if it's a gentle sloping surf zone that's causing the wave to break. Non-breaking waves can either be rogue waves or tsunamis. Rogue waves are created by wave construction, as best we can tell, these huge waves that appear out of nowhere and could potentially capsize ships. Tsunamis are these gigantic waves that are created by earthquakes that don't break when they get to shore. So that's it. That's really all I want you to understand when it comes to waves. Stay tuned for the next lesson when we'll actually wrap up this first unit on oceanography and we will talk about tides.